Okay. All right, so first example, let's use half angle identities. Use half angle identities to evaluate okay, let's do a couple, we'll do a couple of these. Let's do sine of 195 degrees. Okay, so we're going to use a half angle identity to evaluate sine of 195 degrees. If you'd like to try this out, go ahead and pause the video, right? Try it out on your own. I'm going to go ahead and work out the solution now. So, if I want to use a half angle identity to evaluate this expression, the first thing I need to do is figure out, well, what divided by 2 is 195, right? So like this is the half angle for what angle, right? So another way to say that is, you know, I can multiply this by 2, right? So 195 times 2 would be what? 3, oh, let's see. Let me grab a calculator. Well, that's 390, is that right? 390? 390, I think. 195 times 2, 390. Okay, so this is 390 degrees divided by 2. Okay, and now I can use the half angle formula for sine to figure out what that should be. So for sine theta over 2 is plus or minus square root of 1 minus cosine theta, all divided by 2, right? So this is going to be plus or minus square root of 1 minus cosine theta divided by 2. Okay. So we can make a choice now about whether we should take the positive or the negative square root. We want our answer, right? So the original kind of thing that we're after is sine of 195 degrees. Well, 195 degrees, that's between 180 and 270, so we're in quadrant 3 here, right? Sine is negative in quadrant 3, so we're gonna take the, oh, you can barely see that. I need a bigger red marker. We're going to take the negative square root, though. Right? We're going to take the negative square root here. So now the other thing is that cosine 390 degrees, that's 30 more than 360, right? And remember, cosine is periodic, so I'm just going to replace this with 30 degrees, okay? Because 390 again is just 30 more than 360. So I'm going to say, okay, so this is negative square root 1 minus cosine 30 degrees divided by 2. Okay, the rest is just history, right? I mean, so we can think about what is cosine 30 degrees. Cosine 30 degrees should be root 3 over 2, right? So I'm going to have negative square root of 1 minus root 3 over 2, all over 2. And then there's quite a bit of simplifying that we can do here. Again, this is one of those things where it's like, I'm not exactly sure how your book's going to want the answer, but we can play around with this a little bit and give you a couple different ways to express your answer here. So we can say, well, one thing we could do would be to multiply by 2 over 2, inside of the radical, of course, to try to clear that complex fraction. So we'll say, this is negative square root of 2 minus root 3 over 4, right? So we get that by multiplying by 2 over 2, right? So it's 2 minus root 3 over 4. We still, I guess at this point, we can apply this square root across the numerator and the denominator. And the square root of 4 is just 2. So now this is going to be negative square root of 2 minus root 3 over 2. Okay, but now the square root is only in the numerator, right? Because we took the square root of the denominator. I think that's about as good as it's going to get, honestly. So I'm going to call that good. I think that's my final answer there. The lid for this marker fell down. Okay, got it. So there's sine 195. Okay, let's look at another one. Let's do cosine of 15 degrees. Okay, so now that you've seen part A, now that you've seen part A, I'm definitely going to ask you to pause the video, try out part B, right? See if you can do part B on your own. So I'm going to go ahead and give you the solution now. So cosine 15 degrees, same kind of idea as before. We can say cosine of 15 degrees, well, that should be the same thing as cosine of 30 degrees divided by 2. Well, this is kind of boring. This was completely accident. I just chose these problems kind of at random. We're going to end up doing some cosine 30 degrees again. That's okay. All right, because cosine 30 degrees over 2, now this is going to be plus or minus square root 1 plus cosine theta, theta in this case being 30 degrees, divided by 2. In this case, we're looking for cosine of 15 degrees. 15 degrees should be in quadrant 1, right? So we're going to take the positive square root here, in this case. So we're going to say, all right, so this is the square root of 1 plus 30 degrees, cosine 30 degrees. So again, that's root 3 over 2, right? Cosine 30 degrees, root 3 over 2, all over 2. Okay, and then same tricks as before, right? We can multiply by 2 over 2. And we're going to end up with square root of 2 plus square root 3 over 4. We can apply the square root to the numerator and denominator separately, and then we get square root 2 plus square root 3 over 2. Okay, and that's the answer there. I just suddenly became curious how my calculator expresses the answer. So I'm going to take a look at sine 195 degrees. Let me see. Mode. I was in radian mode. I need to go to degrees. But let's see now. Sine 195. Well, it's giving me a completely different format. It's giving me like square root 6. No, hold on. It's giving me root 2 minus root 6 over 4. Root 2 minus root 6 over 4. Well, I'm going to do some magic. I'm going to think about this, and then I'll try to explain the mystery in the next video. Root 2 minus root 6 over 4. Okay. Well, let's think about it. I'll think about why that's true algebraically.